All right. So first of all, I want to kind of like refresh our memories a little bit about the properties of exponents. Okay, we kind of briefly skimmed over them yesterday. I just want to make sure we're really good to go with those here today. Okay, so okay. So let me just talk about that. Properties of exponents. Review. Okay. Okay, so, and I'll just do this with like examples here, okay, as opposed to like generic like variables and stuff like that. So, for example, right, if we have 4 squared and we multiply by 4 to the third, okay. Before I jump into what the actual property is, let's just break down what it means to take 4 squared and multiply it by 4 to the third, right? 4 squared, when you square 4, what are you really doing? What are we really saying to do? When we take 4 and we square it, what are we really saying to do mathematically? Multiply by itself, right? So in other words, when I have 4 squared, I can say that's the same thing as saying 4 times 4, right? And then when I say times 4 cubed, well, what's 4 cubed the same as? 4 times 4 times 4, right? Okay. Well, I had 4 times 4, and I'm multiplying by 4 times 4 times 4, and now I have 4 times 4 times 4 times 4 times 4, which is 4 to the 5th, right? There's 5 4s there, so we can just say it's 4 to the 5th, okay? Now, of course, we don't want to have to expand that 4 squared and expand the 4 cubed every time we do this, so what's a shortcut that we could take to go from here to here? Add the exponents. Exactly right. Add the exponents. So we get our answer there. Okay? Exactly right. Okay? Likewise, so that's one of our properties right there, okay? When you multiply with the same multiply 2 numbers with the same base, you add the exponents. Okay? Now let me change it up a little bit. Let's say I have 4 squared to the third like this. Okay? Now, what did 4 squared mean again? 4 times 4. But I'm cubing that 4 times 4. So that means I'm going to have 4 times 4 times 4 times 4 times 4 times 4. Right? If I cube 4 times 4, I've got 1, 2, 3 of those pairs of 4s all multiplied together. Right? 4 times 4 times 4 times 4 times 4 times 4. Which is how many 4s? 6. So it's the same as 4 times 6. 4 to the 6. 4 to the 6. Okay? But of course, we don't want to have to expand this out every single time, right? When we do this, it's a lot. I mean, you could, if you forget, you could, right? But instead, what's a shortcut to go from here to here? Multiply, right? Okay? Save yourself the headache, right? Just multiply. So when you have a power raised to a power, you multiply the powers to simplify. Easy peasy, right? All right, let's try another one. Okay. We'll also talk about division. Okay. I'm going to get a broom, start quiet down up there. All right. 4 to the third, that's the same thing as 4 times 4 times 4, divided by 4 times 4. Okay. Now, with it expanded out like that, how can we simplify? Were you going to say something? Go ahead. Okay, well, we'll see. We'll see. So what happens here with the 4s? Can we simplify it all here? We have some 4's in the numerator, we have some 4's in the denominator. Does anything cancel? Well, we got a pair of 4's here. That can cancel. We got another pair of 4's that can cancel. And so what's left in the numerator? 1, 4. And what's left in the denominator? Not nothing. We're dividing here. So when you say nothing, that would mean the number 0, right? What number would be left down here? A 1. Yeah, but we're going to leave it as just, we're just going to rewrite it as 4. Or 4 to the, what exponent would this be? 4 to the 1. Okay. So, right. So how can we go quickly, again, shortcut-wise, how can we go from here to here quickly? What are we really doing? Subtracting. Yep. It's 4 to the 3 minus 2, and that gets us to there, 4 to the 1. A few other properties here, just like, some basic ones here. 4 over x to the third, like this. Okay. 4 over x to the third means 4 over x times 4 over x times 4 over x, right? Which is then just really the same thing as 4 to the third over x to the third. So in other words, we can distribute that cube, okay? If you have a quotient raised to a power, you can distribute the cube to the numerator and the denominator there, right? So instead of writing 4 over x times 4 over x times 4 over x, or whatever, we just cube the numerator, cube the denominator there, okay? If you're cubing, or have a fraction raised to an exponent there. Okay. Likewise with a product. If I have 4 times x to the third, okay, if I have 4 times x to the third, that's 4x times 4x times 4x, which is really just 4 to the third. If I rearrange the numbers, right, it's 3 4's and 3 x's being multiplied together. So it's 4 to the third, x to the third. Right? Okay. So in other words, over multiplication, you can kind of distribute and stuff like that. Right? But what about this? If I have 4 plus x to the third, if I have 4 plus x to the third, does that equal 4 to the third plus x to the third? In general, no, it does not. Okay, no, it does not. Okay, if you don't believe me, you can put a number in there for x. If you really don't believe me, so let's just imagine if you put a 2 in here. Okay, put a 2 in for the x. Okay, if this is true, right? If this is true, then 4 plus 2 to the third should be the same thing as 4 to the third plus 2 to the third, right? If I can just distribute like that. Well, 4 plus 2 is going to give me 6, and 6 to the third is 36 times 6. 216. Okay, 4 to the third, though, that's 64. 2 to the third, that's 8. Does 64 plus 8 equal 216? No. Okay, so in general, these will not be equal. Okay, so you cannot just distribute a power. Okay, remember when you cube something, that means you're multiplying it by itself 3 times. So in other words, this would be 4 plus x times 4 plus x times 4 plus x. That goes back to like our polynomial stuff when you're multiplying out, polynomials and things. Okay, so be careful about that. Bless you. Okay, don't do that. So there's our properties, right? And again, this should be reviewed, but it's good, to see it again just in case. So again, when you multiply 2 numbers at the same base, add your exponents. And by the base, I mean the 4, right? So when you have 2 numbers that multiply and the same base, add exponents. When you have a power raised to a power, you multiply the exponents, so you get the 6 there. When you divide, you do and the same base, you subtract the top exponent from the bottom, or top exponent minus bottom exponent. And then when you have like division or multiplication and to a power, then you can just distribute that power to the individual pieces. All right, super important, because we're going to be using those properties here today. Okay, so let's, yeah. So let's see this in action now with some rational exponents. Okay, so let's say, for example, so just simplify the rational exponent expressions. Okay, so let's do like 25 to the 3/5 times 25 to the 7/5. Oops, I'm off the screen. There we go. And I'll try and zoom in some there since I'm writing pretty small. Okay. Question? Yes, before though, you need to answer this question. How do we simplify this here, Gio? What can we do to simplify this? What can we do with our exponents? We have the same base, and we're multiplying, so what should we do with our exponents? Add them. That's right. Okay? So yes, folks, we're going to be doing fraction arithmetic here. So this is going to be equal to 25 to the 3/5 plus 7/5 exponent. Okay? Gio, what is 3/5 plus 7 more fifths? 10/5. Yeah, well, so 10 divided by 5 simplifies to 2. So it's 25 to the 2. Okay? And 25 squared is 625. Okay, thank you, Gio. You can go now. Just wanted to make sure you were okay with stuff before you headed out. Okay? Good, good, good. All right, let's try another one. All right, let's see here. 8 to the 1/3 divided by 8 to the 2/3. All right. Let's go to Kyler. So Kyler, we are dividing here. We have the same base, okay? So since we're dividing, what should we do with our exponents to simplify here? So we are dividing, right? We have the same base. So how do we simplify exponents if we are dividing? What can we do? Okay, combine them using what? Okay, so be careful. When we multiply, Tyler, we add the exponents. So when we divide, it would make sense to do what? Subtract. There we go. That's right. So this is 8 to the 1/3 minus 2/3 power, which 1/3 take away 2/3 is going to be negative 1/3. Negative 1/3. Okay? Now, when you have a number to a negative exponent, that is the same as 1 over that number to a positive exponent. Okay, that's another little property right here. Okay, so we have 8 to a negative exponent. That's the same as 1 over 8 to the 1/3. But we can go even further here because what does 1/3 power mean? Cube root, right? What's the cube root of 8? What times what times what? What times what times what? 2. It's 2, right? It's 2. 1 over 2. 1 over 2. Okay? Now, if you want to see this with even more exponent properties here, let me just show you a little intermediate kind of step here. I'm going to kind of go this way. All right, so I could rewrite 8 as 2 to the 3rd, right? So I could take that 8 to the 1/3 and rewrite it as 2 to the 3rd to the 1/3, couldn't I? Right? 8 is 2 to the 3rd, so I'm going to rewrite 8 as 2 to the 3rd, and I still have to raise it to the 1/3 power. But now I have a power raised to a power. Right? How do we simplify when you have a power raised to a power? How do you simplify your exponents? What's 3 times 1/3? What's a third of 3? 1. And look at that. We get 2 to the 1. Isn't that a 2 to can I put a 1 in there? Okay? So you see it simplifies, if you really want to get down to the nitty-gritty of the exponent properties there, okay? It simplifies that way too. But of course you can also just remember, oh, that's a cube root. Cube root of 8 is 2. Your choice. Okay? So far, so good? All right, we'll do 2 more here together, and then I'll have you guys try some, just to make sure we're good here. Okay. All right, moving on up. So let's try this one. Y to the 4/3 all over 16y to the 2/3, that raised to the 3/2. Whoa. Now, the more complex these get, the trickier it can be here. Not trickier, but the more choices we have. I can see at least 2 options here about how we can proceed. Okay? Option 1, I see a y in the numerator, and I'm looking inside the parentheses here. I see a y in the numerator, a y in the denominator, and so we're dividing, so what can I do with their exponents? We could subtract them, right? We could subtract. That's option 1. Option 2 is this whole quantity here is being raised to the 3/2. And since it's all multiplication or division in here, I could distribute that 3/2 to each of these 3 parts. So I could do y to the 4/3 to the 3/2, 16 to the 3/2, and y to the 2/3 to the 3/2. Okay? So you could do that as well. You have 2 major choices to go with here. Either one, as long as you continue, what will lead you to the same answer. So I'm going to do the first one here. Okay, I'll do the first one. So we're going to rewrite this y to the 4/3 over y to 2/3. I'll make that. And be careful here, folks. That 16 is in a denominator, so it's really 1/16. Yeah, bless you. That 16 is in the denominator, so it's really 1 over 16 here. Okay, and then I'll do times, and we'll do y to the 4/3 minus 2/3 power. Right, because again, I'm subtracting the exponents there since we're dividing. And then I still have to raise this whole mess to the 3/2. Okay. Now, what is 4/3 take away 2/3? It's 2/3, right? So I end up with 1/16 times y to the positive 2/3. But then I'm going to raise everything to the 3/2. So everything gets raised to 3/2. Okay, 1 to the 3/2. Well, that's going to be easy. It's just going to be 1. So I got 1 over 16 to the 3/2, and then y to the 2/3 also to the 3/2. Okay, so 1 got raised to the 3/2, but it's just a 1, right? 16 got raised to the 3/2, and then the y to the 2/3 got raised to the 3/2 as well. Okay. All right, now 16 to the 3/2. All right, we can do this. Well, I'll simplify that here. Okay, we have kind of 2 options here. All right, the over 2, right, the halves part there. Let me see if I can zoom in some better. There you go. Okay, that over 2 means we're going to do what to the 16? The 2 in the denominator here for our exponent means we're going to do what to the 16? Square root. What's the square root of 16? 4. And then the 3 means we'll raise that to the 3rd power. And so that becomes, what's 4 times 4 times 4? You know, it's 64. So we're going to have 1 over 64 there. And if you're not comfortable with that, you're like, Mr. Witt, I don't know if I'm going to be able to remember all that. I mean, you can. I mean, it's just square root the 16 and then cube it. But you can also remember just type it in your calculator, okay? You can type in 16 to the, and then in parentheses, 3/4. Oops. Sorry, it was 3/2. And there's your 64 that you get. Okay? So you can just type in the fraction there. It'll work. Okay? Now, what about here? We have a power raised to a power. How do we simplify that? A power raised to the power. How do these simplify? What do we do with our exponents? Multiply. Okay? 2/3 times 3/2. Well, it's going to be 6 over 6, which simplifies to what? 1. Yeah, so we get 1 over 64 times y. Okay? So all that mess, all this mess right here, simplified down to 1/64th y. Or you could say y over 64 if you like. Okay, you can put that y from the numerator there if you like. And there it is. All right, I do want to do one more. Yeah. Yes. one more here. Anyone still writing? We're good? All right, I'm gonna go to this little white space I got up in here to use it. Okay. All right. One more, and I'll give 2 for you guys to try. 27x to the 3/4. That whole mess raised to the 2/3 power. Okay. If I look inside my parentheses here, is there anything I can do to simplify inside my parentheses? No. So we'll just distribute the 2/3 to the 27 and the 2/3 to the x to the 3/4. So we'll have 27 to the 2/3, and then we'll have x to the 3/4, also to the 2/3. Okay. So 27 to the 2/3, well, again, you can type that in your calculator if you really want to. Okay. But we can also do this mentally, right? What does the 3 in the denominator mean? Cube root. What's the cube root of 27? 3. And then the 2 means we're supposed to then take that and square it. So what's 3 squared? 9. So this just simplifies down to 9. So mental math. Okay. Very easy. It's so simple. Okay. Power to a power. How do we simplify that? Multiply. So to multiply fractions, you multiply across the top, multiply across the bottom. So 3 times 2 is x to the 6th, and 4 times 3 is 12. And of course, 6/12 simplifies to what? 1/2. You got it. And that's our final answer. Okay? Just like that. When Patrick comes back, yes. All right. Ready to try some on your own? Sure. Oh, yes, I got an answer. Very good. And an affirmative, too. So that's good, too. That's good, too. I don't know what I would have done if you guys said no. I guess I would have said, too bad. All right, here, try these. Okay. So that's 12 to the 2/3 times 12 to the 4/3, all to the 3/2. And then I'll give you this one too, so I can fit it on there. Okay. Oh, good, they fit. Okay. There you go. So yep, see what you can come up with here. All right, you got 3 and 4. Okay, assume all variables are positive, and please also simplify any negative exponents. So rewrite anything so that you have no negative exponents too. Okay, so you should not end with any negative exponents. Rewrite it so that you don't have any negative exponents. So see what you can come up with here. Now 3, technically, since there's no variables in here, you could just type this whole mess in your calculator if you really wanted to. Okay? Since there's no variables, you can type this whole mess in your calculator and just get an answer. Now, if it has roots left in it and stuff like that, it's gonna give you a decimal. Let's see here. Does this one give you a decimal? Oh no, this one will be nice. So you could do that, but try and use your properties there. And then number 4, well, you got variables, so you can't use a calculator for that. So go ahead, try those two. Okay, give those two a try there. See what you can do. have a good start for our new term, okay? All started with stuff. I know, Wednesday. Wednesday, you'll have a couple days. Yes. Anyone need any help? Questions? Then you cube it, that's right. 1728 is what you should get. Kyle, you doing okay? Do you have any questions on any of this? Okay. So remember here, when you square, right, 6 gets squared as well. So it should be 36 that you get right there. Okay? And then x to the 1/3 to the 2, you multiply those exponents. So it should be 2/3, not 3/3 there. It's x to the 1/3 to the 2, right? That, the x to the 1/3 is being squared. So you multiply the exponents, you get 2/3 there. Okay? That will stay 5/3. Notice it's not in the parentheses, so it stays 5/3. And then you'll do the subtraction to simplify the exponents and stuff from there. Okay? Yeah. Okay. So I would encourage you to distribute the 2, both these. So it becomes 6 squared, which would be 36. And then you have x to the 1/3 to the 2, so those exponents are going to multiply, so it's 1/3 times 2. You can get that in. 2/3. So x to 2. And all over. And now you have the same base, so you can subtract next to the 2/3 x to the 5, subtract your exponents there. Everything since the benchmark we're using now. So basically it's No, I don't think so. I think it should be good. If you just like, so basically it's like all the stuff we've been doing since this week, right? Because we had the benchmark Friday last week. Yeah. So it's everything we're doing this week and then Monday. Yes, that's right. Mm-hmm. Yeah, one in the denominator, just like that. Yeah. Yes, that's as simple as you can get it. All right, Tato, I'm coming and they're ready to work. What's up?
36.
In the denominator then as a positive. So I'll show you here. I'll show you here what I do to kind of help clarify, because you're right. It's like, okay, is it x to the -1 in the numerator or is it x to the -1 in the denominator? So I'll show you. Shh. Okay, here we go, folks. Let's take a look. There's the first one. Okay. Now, I am really breaking it down step by step here. Okay, I'm really breaking it down step by step. If you don't want to take this many steps to simplify, you don't have to. Okay, You also didn't have to simplify in the same order that I did. Okay, so for example, you could have distributed the 3/2 power to each one first. You could have done 12 to the 2/3 to the 3/2, 12 to the 4/3 to the 3/2, multiplied and then done stuff. Okay, I went ahead and did the multiplication. I took care of what was inside the parentheses first here. Okay, so we add the exponents, we get 6/3. Okay, but what's 6/3? It's really just 2, right? Okay, and then I have a power raised to a power, so we multiply. So twice 3/2 is 6/2, okay, which divides to 3. And then I went ahead and made it 12 to the 3rd, which is then 1,728 if you did actually multiply it out. Okay, but of course, the nice thing about one of these numeric expressions is if you have your graphing calculator available, you can literally just type that whole mess in your calculator and it'll spit out 1,728. So, all right, now this next one, a little bit trickier because we have those variables in there. All right, so first thing I did here, we can't touch this x right here because it's in parentheses and it's being squared. So we can't subtract straight off the bat, right? Because that x here is in parentheses and it's being squared. So we need to square both the 6 and the x to the 1/3 first. So we get 6 squared equals x to the 2/3. Okay, because again, 1/3 times 2, 2/3. Okay. Now here's again just a recommendation I'll make here. We can see that these x's, right, they have the same base, so we'll want to subtract their exponents. So what I did is I took the 6 squared and the y, and I made that 36 over y, right? That makes sense, right? And then I pulled out the x to the 2/3, x to the 5/3 outside that fraction and did this, times x to the 2/3 minus 5/3. Okay? So I took these two things, and I kind of pulled them out of the fraction and just multiplied by their subtraction there, of the x to the power subtracted. All right? 2/3 take away 5/3 is negative 3/3, which is negative 1. And then since I'm multiplying by x to the negative 1, I change that to times 1 over x. And then you can see the x ends up in the denominator there to get the 36 over yx, or xy if you like. Okay? So that's the idea there. Question? Yes. Okay? Okay, so I want to show you 2 more problems here because we have not talked about anything. Right? I entitled these notes Simplifying Radical Expressions. We have not seen any radicals yet. No radicals. But I'll show you 2 with some radicals here, and I think you'll get the idea from there. Okay, so let me just show you 2 problems with some radicals, and we'll get the idea from there. Okay? Excuse me. Okay, so let me start with an example here. Let's do something. Let me see here. I want to start with that one first. Yeah, okay. Let's say we've got the cube root of 256 x to the 3rd, y to the 7th. Okay? And again, we just want to simplify. Okay? We have not yet talked about simplifying with cube roots in it. But we can rewrite cube roots as what exponent? What exponent is the same as cube root? 1/3. So we're going to rewrite this as 256 x to the 3rd, y to the 7th to the 1/3 power. And then what can I do with this 1/3? Well, we'll just distribute it to each term here, or each part of our little product there. So this is the same thing as saying 256 to the 1/3, x to the 3rd to the 1/3, and y to the 7th to the 1/3. Okay? Cube root of 256, I think it's 8. Check that here. Ooh. It's not. Mr. Witt, it doesn't simplify nicely. Oh, okay. I see what's going on here. Okay. pause real quick there. All right, so okay, I'm going to be careful here now. All right, so 256 is not a perfect cube root, but it is a power of 2. So let's see here. 256 is 2 to the 8th, I think. Okay, so I'm going to rewrite that as 2 to the 8th. Okay, I'll go ahead and simplify these, though. So it's still to the 1/3 there. All right, x to the 3 to the 1/3 will become x to the 3/3. And then y to the 7 to the 1/3 will become y to the 7/3. Okay, bless you. Bless you. Okay, and so then I'll go ahead and multiply these exponents here. So we get 2 to the 8/3, x to the 3, x to the 1 now. I guess I'll just go ahead and make the x to the 1. And we have y to the 7/3. Okay. Yep. And we're going to stop right there for now. We have a little bit more simplification that we can do with this, but I'm going to hold off on that simplification. I'm going to do that. We'll worry about that some tomorrow. So we'll stop right here, but there is a little bit more we can do, okay, but we'll stop right there for now on that because I don't want to go too far. And that maybe is just one more step that I want to take today. Okay, so we'll stop right there for now. All right, so because we simplified everything we pretty much could, but we can do some stuff here with these improper fractions. All right, I'll show you one more here, and then I'll get you guys started on your assignment. Okay, one more here. Okay, so again, we see some cube roots, right? And if we have a cube root, that is the same as what exponent? 1/3 power. So I'm going to rewrite this as 2y to the 1/3, and I'll rewrite this as 4x squared y squared to the 1/3. Now, since both of these quantities have a 1/3 exponent, okay, since the 2y has a 1/3 exponent and this quantity, 4x squared y squared, has a 1/3 exponent, and we're multiplying, we can actually put this all together under one 1/3 exponent there. Okay, do you see what I did here? 2y was to the 1/3, 4x squared y squared was to the 1/3, and we're multiplying, right? So then I brought the whole product, 2y times 4x squared y squared, whoops, y squared, not y to the 4th, Mr. Wade. Okay, y squared, all right, and I put that all to the 1/3 power. Because we can simplify this first here, right? We can do 2 times 4, we'll get an 8. Okay, y times y squared will give us y to the 3rd. Okay, and now I'll redistribute that 1/3. So we'll get x times 8 to the 1/3 times x squared to the 1/3 times y to the 3rd to the 1/3. Just like that. Okay. So I'm going to distribute the 1/3 to each one of the 3 terms here. Okay. So I'm going to have to go this way. I'm running out of space. What is 8 to the 1/3 power? Or in other words, what's the cube root of 8? 2. And then x to the 2/3, because we're multiplying there. And then y to the 3/3. Okay. Now I have another x here, though. What's the exponent for this x right here? 1. And so I have to add these exponents. Okay. So I have to do 1 plus 2/3. Again, you can do that in your calculator if you want to. Just type in 1 plus 2/3, hit math, enter, enter, and then to get your answer, it's going to be 5/3, right? 1 is the same thing as 3/3. So I have 3/3 and 2/3 makes 5/3 there. Yeah. I'm out. I need to go get some. I'm sorry. Actually, I might have some spares there. Hang on. Hang on, I'll get you some. I got some in my 3/3, which is just 1. Sorry, it's just about 1. All right, now I really made a mess. Let me go up here. 2x to the 5/3, and then y to the 1, or just y. Okay, again, I did the x to the 1 plus x to the 2. 1 and 2/3 makes the 5/3. We have the 2 there, and then the 3/3 becomes just 1. Okay, so there it is at the very end there. All right. That's the most complicated it's going to get for today. All right, we'll add, like I said, I had one more step of simplification I want to do for that next to last one, but we'll go over that